We're going to start chapter 6 about trigonometric functions. The next 3 chapters, we're going to start looking at a new kind of function that's different than algebraic functions. Algebraic functions are those that are defined by using operations on numbers. Trig functions are widely applied in calculus, in sciences and engineering in particular, so we need to learn about their definitions, their outputs, their properties, and their graphs. Let's start. Section 6.1 is about angles and their measure. Angles? Geometry? Well, kind of. The trig functions have angles as their inputs. The first thing we need to know about is something that's called an angle in standard position. This is an x and y axis, and I'm going to draw an angle that has one ray along the positive x-axis and one ray somewhere else, and the vertex of this angle, or where the two come together, is going to be right here at the origin. Yeah? So this is what we call an angle in standard position. This side we call the initial side, and the side here we call the terminal side. Okay? All right. We give a value to the size of an angle about how open it is with a number and a direction. Right? So we're going to have what we call positive angles. Right? And a positive angle is an angle like this. If the horizontal side is the initial side of the angle, and we think about, we think about this angle kind of opening, starting on the initial side, and then kind of opening in this direction, right? As if both rays were laying on each other, and then we have one of them open up in a counterclockwise direction. We call this a positive angle. So this is counterclockwise rotation. But we also have angles that are negative angles. If we think of the horizontal as the initial side and the other side as the terminal side, and we think of the angle opening up from its initial side to its terminal side, then we call this a negative angle with clockwise rotation. Yeah. In math in general, we like to name angles with their measure. We'll call this one alpha and this one beta. We use Greek letters quite a bit. So alpha and beta are the first 2 letters of the Greek alphabet. Yeah. On a coordinate plane, these 2 angles that I've just drawn aren't on a coordinate plane, but on a coordinate plane when an angle is in standard position, we say that that angle lies in whatever quadrant its terminal side is in. So for example, let's say, here's my coordinate plane, and let's say I have an angle whose initial side is lying on the x-axis, and its terminal side is here, right? I'm going to call this angle theta. That's another very common letter that we use to talk about angles. I see here that theta is positive because it's opening in a counterclockwise direction, but also we say that theta is in what we say quadrant 3. Yes, because the terminal side lies in quadrant 3. Another example, let's take a look at an angle whose in standard position, so its initial side is along the x-axis. Its terminal side is here. This angle is going to open all the way around this way. We'll call it theta. In this case, theta is a negative value, right? Because we're opening clockwise. But theta is in quadrant 1, right? Because the terminal side ends in quadrant 1. Okay, when we're measuring angles, there are two types of units that we use. Units of angles. One that you're probably pretty familiar with is the idea of a degree. It's more commonly used in, not in math. And one that you're going to find out that we use more commonly in math is radians, okay? The reason that radians are used as opposed to degrees is that it makes a lot of calculations in calculus a lot easier. Yeah. Okay, but first let's talk about the familiar idea of a degree, right? And we all know that a degree can be notated with a little tiny circle up in the right-hand corner of something. Okay, if I draw an angle whose terminal side and initial side lie right on each other, meaning that the rotation happens all the way around, we call this 360 degrees, right? So we can think of one revolution as 360 degrees. That then tells us that 1 degree is 1/360th of a revolution, right? So that's how big a degree is, right? It's a tiny little thing that's equal to 1/360th of an entire, rotation all the way around, okay? Then we have an angle that you're probably familiar with, 90-degree angle, right? A 90-degree angle or a right angle. How many revolutions is it? Well, according to our picture, it looks like about 1/4 of the way around. Well, if 1 degree is 1/360th of a revolution, then 90 degrees is 90 times 1/360th of a revolution, right? That's the same thing as 90 over 360, which reduces to 1/4 of a revolution, right? And we see that that's the case here, yeah? One more angle that's important to know its degree measure is something that we call a straight angle. Here's the vertex. The angle opens this way. We call this 180 degrees. So we say 180 degrees is a, quote, straight angle. Well, I didn't write this, but the 90 degrees is a right angle. We can also have angles that are larger than 360 degrees. Let's take, for instance, a 405-degree angle. Our initial side will be horizontal, and our terminal side, if we open up counterclockwise, go all the way around once, and then, so this would be 360 degrees around, and then an additional 45 degrees, we get 405 degrees, right? So you can see that angles, we don't have to have the largest one be 360. You could go positive and negative, with angles whose absolute value is bigger than 360. Now, angles that are measured in degrees can also have degrees, minutes, and seconds, right? What are minutes and seconds? Well, 1 minute is equal to 1/160th of a degree. Sorry, 1/160th of a degree. We notate it 1 with a little line, a single line. Yeah? Or you can think of it as 1 degree equaling 60 minutes. So these are like fractions of degrees. 1 second is equal to 1/160th of a minute. We use 2 little lines to notate a second, or you can think of it as 1 minute equaling 60 seconds, just like on the clock. Let's convert 50 degrees, 6 minutes, and 21 seconds to a decimal in degrees. So we see that we have 50 degrees already, so this is 50 degrees, right? The 6 minutes, right? We know that for each minute there is 1 degree. Oops, I'm sorry, we don't need them equals, we need a times. So 1 degree per every 60 minutes, right? If we multiply this across, we get 6/60ths. Our minutes cancel, we're left with degrees. So that's 1/10 of a degree, or in decimals, 0.1 degree. All right, now we're going to take our seconds. So here's our 21 seconds. And what we can do is we can say, okay, well, there's 60 seconds in 1 minute, and there is 60 minutes in 1 degree. So here the seconds cancel, the minutes cancel. We're left with 21 over 360, and that's approximately 0.0058 degrees. So, all in all, we know that 50 degrees, 6 minutes, 21 seconds is the same as 50.1058 degrees, right? So those minutes and seconds become fractional parts of the degree. We can also convert the other way. We can take a quantity or an angle that's written in fractions of degrees, like 21.256 degrees, and we can put it in degree, minute, second form. That's what that means, degree, minute, second form. Okay, well again, we already know that the 21 is in degrees. So that's our number of degrees. What we're going to do then is we're going to take our 0.256 degrees and put that into minutes and seconds. All right. So if we take 0.256 degrees, first what we're going to do is say, okay, there are 60 minutes in 1 degree, right? If we carry out that multiplication, 0.256 times 60, we get 15.36, and now we're in minutes, right? So it's 15.36 minutes. So the 21 is degrees, the 15 is in minutes. Now we have to take the 0.36 minutes and put that into seconds, right? Because it's a fraction of a minute. 0.36 is less than 1. It's a fraction of a minute. How many seconds is it? Well, we know that there are 60 seconds in 1 minute. So 60 seconds in 1 minute, right? If we carry out this multiplication, we get 21 degrees plus 15 minutes plus 0.36 times 60 is about 21, or is 21.6, and we're going to go ahead and round to the nearest degree. So we're going to say this is approximately 21 degrees, 15 minutes, and 22 seconds. And we can lose the pluses because the form of the number doesn't have those. Yeah. All right, in my next video I'm going to talk about radians, the other measurement for angles.